In this example, we're going to sketch a slope field for a given differential equation. So if we read here, it says, given the differential equation below, compute the slope for each point indicated on the grid to the right. So I'm going to highlight that right here, that we've got a given differential equation. So the slopes of all the tangent lines are equal to x minus 1. We're going to make a small mark that approximates the slope through the point. To start this one off, we're going to just arbitrarily choose any point that we want, and I'm actually going to try to pick this one right here. I think that'll be easy to show you on the screen. So the point -2, 1 is what we're going to use first. If we think about the point -2, 1, we're going to try to actually figure out what the slope of the tangent line will be there. To do that, we're going to take the x value and substitute that into the expression for dy dx. So we'll do our first point here, and our first point we said was -2, 1, and we're going to use dy dx here to figure out what the slope of the tangent line would be at that point to the original curve, which would be y is equal to. To do that, we're going to look at our x, and our x is -2 here. -1 is going to give us the slope of the tangent line at the point -2, 1, which happens to be -3. So I'm going to do my very best to draw a little line with the slope of -3. We can do the same thing for the point -1, 1. So if I pick the point -1, 1, then dy dx will be -1 minus 1, just substituting in for the x, and that gives us a slope of -2. So I'm going to try to draw my very best slope of -2. It's a little less steep than the -3 that we drew before. Now let's just think about the next point over here, which is 0, 1. So 0, 1 has an x value of 0. And once again, if we look over here at our differential equation, when x is 0, 0 minus 1 is -1. So I'm going to try to draw the slope of a tangent line being -1. When x is 1, 1 minus 1 is 0. So we do want to draw that horizontal line right here at the point 1, 1. When x is 2, 2 minus 1 is +1. So the slope of that tangent line is going to look just like this. If we think about the equation or the expression here for all the slopes of the tangent lines, x minus 1, we also notice that there is no y value in there. So vertically, all of these slopes have to be the same. Think about it. If we choose the point -2, 2, which is right up here, -2, 2 has an x value of -2, which is the same as the x value for the point below. So the slope will have to be the same there. Let me erase what I drew there. We'll go back to drawing our tangent lines. So what I'm going to do here is I'm just going to try to draw a slope of -3 here for every single point that's lined up vertically, because that y value doesn't matter. So we're going to go ahead and just try to draw that slope of -3. And then when x is -1, all of those slopes are -2, so it'll be a little less steep. We don't want to shallow it out too much, or that might be a slope of -1. So we'll try to draw that just like this. And then here when x is 0, the slope is -1. So we're going to try to draw this. Almost looks like a 45-degree angled line here. So we'll draw that here and here. And then we do want to draw those horizontal lines for any point that has an x value of 1, because 1 minus 1 is 0. And you guys might be noticing there that a shape is starting to appear. If you had to draw something that had all of these tangent lines, if you picked a point and just drew a shape, Let me show that to you with a different color here. So we'll do blue. It doesn't say to do this in the question, but it's kind of neat to try it. If we just picked a point like maybe 1, 1, and we tried to draw a curve that had all of these as slopes of tangent lines, the curve would kind of look like this. So the deal is when we draw a slope field, it's giving us information about what the original function might look like. Let's take a look at our differential equation, which is dy dx is equal to x minus 1. And if we did find the antiderivative of that, we'd wind up finding y. So y is equal to, and the antiderivative of x is x squared over 2. The antiderivative of negative 1 is negative x. And then, of course, we need our plus c. So that's kind of where we're going in the future with this. And you can tell now that the original equation is quadratic, and it's going to look like a parabola. And the c value here represents a vertical shift. So this blue graph that I've just arbitrarily drawn right here through the point 1, 1 could be shifted vertically up or down, and it would look just the same.